Hey guys, welcome back. We're going to be covering solving quadratic equations using the square root method, or also known as the property. This will involve putting all radicals in simplified radical form, exactly what you guys did last night. So notice if we look down here, just taking a sneak peek at what's to come, these are all quadratics. Okay, we know they're quadratics because the highest exponent in each of these equations is 2. And these are perfect equations, and we'll go over this to use the square root property. I will show you in the first one, just like most of them, you can factor a lot of these, not all of them. So you'd have to use another method, but number one, you could factor that. That is one that you can solve right now without knowing the square root method. All right, the square root property says this, all right, if you have a quadratic and it's equal to a value. So if x squared equals c, then you can take the square root of both sides, and the result would be x equals positive negative root c. Okay? So notice that we get two roots here. We get root c, which is positive root c, and we get negative root c. Now, obviously, if c is a perfect square, then the square root of the perfect square would be a whole number. We would get the positive and negative whole number, but it's not always going to work out like that, as we know, using simplified radical form. Okay, so keep that in mind. So the idea here, it would look something like this. If we end up having a quadratic, I would take the square root of one side. Whatever I do to one side, I would do to the other here. The square root of x squared, well, x squared is a perfect square of x times x, so the square root of x squared is x. And on this side, we would get positive negative root c. We would get both roots. Super important to remember that symbol. That symbol, if you don't have it there, you're really only saying there's one solution, root c. With that symbol, we're saying there's two solutions. So let's get started. We're going to be using this property. But the first question that has to come to mind is, why can we use this? Okay, well, we know right now one of the methods we have for solving quadratics is factoring. So I'm going to look at this two different ways. Okay, we know if we're going to solve this using factoring, there's two criteria that have to be met. The first one is that this quadratic has to equal, hopefully you're thinking, 0, okay, and it does not. So the first thing we're going to do is we're going to subtract 16 from both sides so that this side, the right side, is equal to 0. So on the left-hand side, I would have x squared minus 16, and this is known as a difference of two perfect squares. And just like we saw in the last unit, we can factor that down to x minus 4, x plus 4, and then we would set those factors equal to 0, and we would get x equals 4 and x equals negative 4. So we get our two solutions here. Okay, and that's a good method to have. Sometimes that's the only method that's going to work, is factoring. Actually, there's a method that works for all of these. It's a little bit longer, and you guys will learn it, and it comes with a really big formula that's a pain in the butt to use, but it's effective. Okay, the square root method here would be much easier, and if we look at all these problems, all these we're going to be able to use the square root method. Okay, and the reason why is because if you notice, there's no x term, right? So for the quadratics we've been dealing with, we've had ax squared. We have to have that square term for it to be a quadratic. We then would have a bx term where there's an x in the equation, and then we have our constant, okay? And this is our typical quadratic that we've been seeing, but these are missing this x term. Okay, and when that's the case, what we want to do is we want to isolate, we want to get the square term by itself, which it is here, and then we want to take the square root of both sides, okay? So the square term is all by itself. We could take the square root of both sides. Don't forget about what the property states up here. If I take the square root of both sides, then x would be a positive root and a negative root. So we come down here, the square root of x squared is x, and we get the positive and negative root, and the square root of 16 is 4. So yes, you could see this method is much more efficient than factoring. The only difference here is with these, sometimes you can't factor them. Like if we go to number 2. If we go to number 2, if I were to bring the 18 over, 18 is not a perfect square. And I would get stuck here if I was trying to use factoring to solve for x. But since that x term is missing, all we have is the x squared term, I can go right ahead and use the square root property, take the square root of both sides, and I get positive negative root 18. Now this is the thing. Root 18 is not simplified. So we're going to use what we learned yesterday. I'm going to think of the largest perfect square that goes into 18, which is 9. I'm going to take out the square root of 9, which is 3. And my final answer is positive negative 3 root 2. Okay. Next week we'll be having a Google Live session after Memorial Day, and I'll just meet with you guys and see if there's any questions, because this is really important. I don't want you going on to Geometry Honors without having this. It's super helpful and required. Okay, so we take a look at number 3. Okay, this is another one that's set up perfect for the square root method. It's missing the x term. However, the x squared term is not by itself. There's a negative 32 on this side, and there's a 5 in front of the x squared term. So before we can use this property up here, notice it says that if x squared is equal to a number, then you can apply the property. So here there's a lot more going on, and that's not a big deal. We know how to deal with this. We're going to add 32 to both sides to move the 32. I get 5x squared equals 40. We're going to divide both sides by 5, and I get x squared equals 8. Now this is set up perfectly to use the square root method. I'm going to take the square root of both sides. I don't forget my symbol, positive and negative, and the square root of 8, I can think of that as 4 times 2 now. We should be getting pretty good at this. 4 times 2, so I'm going to pull out a 2. And that leaves us with a 2 inside the house. Okay. So we could see here things start getting a little more complicated. All right. If you just think about this for a second, some of you guys go, okay, yeah, I can multiply all this out. I could bring the 16 over, and maybe you can use factoring. But notice the square term, and I know here the square term is a monomial, x that's being squared. Here it's a monomial, x that's being squared. Here it's a binomial that's being squared. So for this one, this perfect square is all by itself. So this again is set up perfectly to use the square root property. Now the square root of the quantity x minus 3 squared is x minus 3. You can think of this root and square as being inverses, and they cancel. So we're left with what's in the house, which is x minus 3. On the right-hand side, we get positive negative 4. So keep in mind this 4 is a positive and it's a negative. So watch what happens here. So now I'm going to actually add 3 to both sides. And I still get 2 answers, because keep in mind here we just said x is positive 4 and x is negative 4. So let's take the first scenario. If x is 4, 4 plus 3 would be 7. But we also said x could be negative 4, so negative 4 plus 3 would be negative 1. So there are our 2 solutions. Keep in mind with quadratics, most of the time you end up with 2. You could end up with 1 or really none. And we'll talk more about that, I think, at some point in time. Okay? So let's see. These are not going to work out as nice, but that's all right. It makes things a little more interesting. The good news is the square root, the square is by itself, the perfect square. So I'm going to take the square root of both sides, and we get what's left under the house, which is 2x minus 1, and that equals positive negative 9. Okay, so now we're going to add 1 to both sides. And now I'm going to divide both sides by 2. So I get x equals positive negative 9 plus 1 all over 2. Okay, so we have two cases here. 9 could be positive, 9 could be negative, and we're going to have to find both of them. Okay, so let's say if 9 was positive, positive 9 plus 1 is 10. 10 divided by 2 is 5. So there's one of our solutions, but this also says that 9 could be negative. So negative 9 plus 1 is negative 8. Negative 8 divided by 2 is negative 4. Okay, so those would be our two solutions. Okay, so let's move on to number 6. It's going to present a new problem, and obviously if this was just the same thing over and over and over, I probably wouldn't do them on the video like I did eliminate some of the ones on last night's homework. So just watch our last night's notes. Just watch how we do this. The approach is still the same, okay? We get 3x minus 2, positive, negative. Now, root 27 isn't a perfect square. 9 times 3 could be replaced. So we're going to pull out a 3, and we'll keep a 3 in there. So you can see it's going to get kind of interesting here, okay? I'm going to add 2 to both sides. Divide both sides by 3. Don't forget our symbol there. And this gives us two solutions. Now, you don't know this yet, but you can't add a number and a radical. Okay, so I'm going to make a couple notes here. You can't add a number and a radical. Okay? And you can't reduce these 3's here, the 3 on the outside and the 3 on the outside here. But if this 3, this number, and this number are all divisible, if all 3 are divisible, then reduce. Okay, so those are a couple of important notes there. So 3, 2, and 3 are not, but if this was a 3, 3 can go into all 3 of those numbers, and we would reduce that guy further. And you'll see that. That'll come up, guys, okay? So I just want to point that out. So what does that mean for this problem? That means this is our final answer. All right, I'm just going to switch it and write the radical second. It really doesn't matter, but we have 2 plus 3 root 3 divided by 3, 2 minus 3 root 3 divided by 3. Those are our two answers. We leave it like that. That's simplified radical form, and that's acceptable. Okay? Last problem here. It's talking about a rectangle, and it has a diagonal. Okay? And the diagonal is 25. This makes a right angle. The width is 7, and they want us to find the length. And we've seen the Pythagorean theorem before. It comes up here. It's leg squared plus leg squared equals hypotenuse squared. Okay, this creates a right triangle, so we can use the Pythagorean theorem. So these are our legs. This is the hypotenuse. So we would have 49 plus x squared equals 25 squared. 25 squared is going to be 625. Okay, I'm going to take 625 and I'm going to take 49 away from that. Let's see. So I get x squared equals 625 minus 49 is 576. All right, and then I'm going to use the square root property. The square root of 576 is 24. So that goes in nice and evenly. Now normally we would get a positive negative 24, but obviously with a rectangle we can't have a negative value, and we would put units on it. Okay, so that's using the Pythagorean theorem. Okay, I hope this was helpful for you guys. I think you guys are going to be able to use this for tonight's homework. As I mentioned on Google Classroom, you're going to have to do numbers 17 to 33, all of those. Keep in mind on 29, there are some fractions there, and we know how to get rid of them. So let's make sure we remember that. We're going to multiply everything by the greatest common denominator. All right, guys, best of luck. I'll be in touch, and then we will do some more work after Memorial Day. All right, take care.